I still can't figure out the behavioral mechanics of the purpose behind the neon bulb. It's easy enough to call it a top load, but still not understand why. It's easy enough to say it's a disruptive discharge of a spark, but not know what impact that'll have on the entire circuitry of the Barbosa and Leal earth captor. It's easy enough to say that the AC inverter of Clarence's replication maintains uniformity of voltage throughout the 60 cycle time phase. While outside 60 cycles per second, anything goes. And in that sense, the disruptive discharge of the neon bulb affects all frequencies within the line that are outside of 60 cycles, namely the higher cycles, the higher frequencies. And because the bulb is open-ended as an antenna, it can bleed off something, let's say electrostatic charge, voltage, which means that the voltage of the system now at higher frequencies is no longer uniform. Only at 60 cycles is it uniform. But so what? It still does. I'm missing something. I still don't get it. Alright, let's try this on for size. At 60 cycles per second, the inverter has established a dipole, but outside of 60 cycles per second, the disruptive discharge of the neon bulb establishes a monopole. Now I got a problem. I don't understand monopoles anyway, but that's my best guess. Because the Tesla system of wireless transmission of power was based on a monopole, but I never did try to understand what that meant, the implication. So I don't know what it would mean in this case. I mean, if we're attempting to transmit power wirelessly beyond the free end of the neon bulb, the wire sticking up that's not attached to anything, one of the two legs that's not attached to anything other than the air. Obviously the goal is not to transmit anything necessarily, but the consequence of setting up a similar system, but applied differently. Whoops. Yes, applied differently. You know what this means? This means that Wardenclyffe Tower, the power of Niagara Falls hydroelectric dam that Nikola Tesla set up, was merely the seed power. It was like the battery and the inverter, plus the inverter, of Clarence's replication, in which you just have the seed power, the 1% or the fraction of 1%, that's feeding the system. While Tesla's system was designed to get all of the 100, 200, or 300 factor gain from the Earth itself. That's why he had such an extensive labyrinth underneath Wardenclyffe Tower in the bedrock itself, providing the grounding for the bottom end of that tower, the metallic structure part of that tower. But the top end was the top load to provide for disruptive discharge. So the only difference here is that we're not broadcasting the energy wirelessly. We're feeding it directly into a load. That's the third circuit, the load circuit, or load coil. So it doesn't help me understand Barbosa and Leal any much more, but it does help me understand Wardenclyffe. that he was actually harnessing a huge amount of energy in the earth. Whatever his loads, his remote loads, were requiring, they would be supplied. And that's represented by the 56 grounding rods that Clarence used. All those remote locations on the planet that would make use of that seed signal or seed-powered signal to extract their energy. So what Barbosa and Leal have done, or what Tesla's special generator apparently does, is consolidate the whole theology, the thematic design elements, all the elements, the thematic elements of the Wardenclyffe wireless transmission of power, or any wireless transmission of power, I would imagine. It consolidates it under one roof so that you no longer have remote users, remote consumers. The consumption is done in the same vicinity as the originator of the signal is located, because it's your own home unit. You know, you're on the farm and you're out in the country and you have your own Barbosa and Leal device, so it's your own extraction of energy immediately near the source of where you're providing the stimulus for the extraction to take place. And the reason why 56 grounding rods are needed is probably because we're not trying to target, to shoot for a resonance, a sweet spot resonance to maximize efficiency, other than the number of grounding rods. I mean, that's actually how you variegate the system to find its sweet spot, in a sense, or to make up for lack of looking for a sweet spot, because the system is not designed to filter all resonances to find only the most highly efficient one. The Earth is pretty much going to be doing whatever it does, which might preclude efficiency. Because remember, the Earth, you know, we think we put a straitjacket around science, scientific understanding, that we have to look at everything in terms of efficiency, as if we were a military operation, yet, you know, cutting costs, because that's what a corporate structure does, is cut costs, no different than a military operation. But the Earth doesn't work that way. The Earth doesn't care. The Earth isn't trying to be efficient necessarily. And so that's one of the drawbacks of this system of Barbosa and Leal, is that there is no sweet spot. The Earth will pick its own orchestration, and it may not be for the purpose of our efficiency, our gain. It might be for its purpose, whatever purpose it might be, which may have nothing to do with efficiency. You know, there's a lot of factors involved. This is Mother Nature here, and we have to include all of the factors which have nothing to do with power gain or power usage. And it may seem, it's like a bureaucracy. You've got so many inputs or factors affecting it that efficiency isn't the sole factor. So the only way for me to explain or attempt to speculate the explanation of what is the implication or the impact of a monopolar generation of power, and that is when your generation of power becomes monopolar, there's only one other option left of where a dipole could exist, and that is in the load itself. When the load draws upon a monopolar source, it becomes one end of a dipole, and the monopolar source becomes the other end. So from the standpoint of efficiency, generation of power has reached its maximum point of efficiency when it becomes monopolar. Because now when the load is involved as one end of a dipole, because we have to think of references, we eliminate all the voltage references within a monopolar system, but that doesn't preclude the fact that the load becomes one end of a dipole. So now the monopolar system has been turned back into a dipole, but only with regard to the load, not in regard to itself. So now the load becomes part of the source generation, and that's why the load is involved as a stimulus to actually improve, or increase, I should say, increase the amount of energy coming from the source, the monopolar source. So when the source is monopolar, the load is a factor not in depleting the source's supply of energy, but actually increasing it somehow. And that's, I guess, where the ether comes in to make up the difference. And we don't have to worry about how it does it. We can't meter the ether, right? So it somehow just miraculously provides to make up the difference. Because the load is a negative, I don't want to say a resistor, but it's a negative amperage. Yeah, we could say it's a negative amperage. It's amperage of a reverse polarity, which effectively recharges the source. You know what? I wonder if you recharge the source with inverted polarity of amperage, does that mean that the amperage of normal polarity running through the monopolar system doesn't get kicked out and supply the load? But still, that would be a limited amount. I guess when you're I guess when you're dealing with a monopolar system tied to a vast reservoir, such as the Earth is, the load has no limit as to how much energy it can draw, effectively speaking. That still leaves me queasy. I don't know. Well, no, wait. Let's go back. I said that the load provides oh my goodness. That's the whole point of radiant energy. My only way to try to figure out the relationship, or the rapport, the empathetic relationship between radiant energy and electricity, now that I know that radiant energy moves in the direct opposite to amperage, coexistent with amperage, is to make the analogy with a transistor, in which you've got electron holes versus electron presence. You know, an NPN or a PNP transistor stratification of material. So radiant energy is like the hole that an electron can fill. What if the disruptive discharge, in the course of its bleeding off voltage, electron-based voltage at high frequencies, it has to be bringing in radiant energy of high frequencies in reverse direction, sucked into the system. And in a sense, that's what's powering the load. on one condition. If the load is an inductive load, such that it would alter the characteristic frequency, the high frequencies of the radiant energy coming into the system through the neon bulb. See, so the neon bulb is sucking in radiant energy at high frequency. When that moves into the load, if it's an inductive load, which is designed to run at 60 cycles per second, what if that inductive load alters or changes the radiant energy into normal electricity, so that now the load is generating electric power at 60 cycles per second? That theology, or speculative theology, would apply merely to an inductive load. But what about a non-inductive load? That means it would kick out of the non-inductive load electric power of the same frequency that arrived. No different. It would be high frequency, which would exit the system again through the neon bulb. Actually, it would create a surge that would have to exit out through the neon bulb, which means you're setting up the system for sucking in even more radiant energy at high frequency than before. So now you've got a situation that escalates. So it would appear that the system would run more efficiently if you had a non-inductive load at the load end, as opposed to an inductive load that's geared to run at 60 cycles per second. But that's not to say you could not run an inductive load, because actually, when I think about it, an inductive load is an AC load, right? While a non-inductive load can go both ways. It can be either DC or AC. That means that an inductive load will also create high-frequency power, as well as the low frequency set at 60 cycles. So even an inductive load will escalate create a surge of power that wasn't there before. But it'll create a mixture of both low frequency 60 cycles plus the high frequencies that came into the system in the first place. And it doesn't have to engage enough torque to move the rotor of, let's say, the compressor in a refrigerator to operate. All you have to do is have the on switch on for that compressor motor running the compressor, the electric motor running the compressor in a refrigerator, let's say. All you have to do is have the on switch on, because the radiant energy is going to be going through the coils, and thus the translation is going to be affected anyway. It's just that we won't get anything useful out of it, in terms of rotation of the motor running the compressor, until the power surges sufficiently to turn that rotor and make it run. So there'll be a rise of this surge of electrical energy appearing in the coils that run the motor that power the compressor in the refrigerator, as an example. And that rise will eventually meet the minimum demand required to rotate the electric motor inside that refrigerator compressor operation. So it's not a concern to worry about. The system is already set up to work as a monopolar generator of electricity, in which the load creates a new dipole that's no longer oriented at the source, strictly, no longer confined to the source. Now it stretches between the source at one end and the load at the other. We've created a whole new dipole, and as long as the load wants power, the dipole is not killed. And so long as the monopolar circuitry does not break down, the dipole is not killed. So here's the secret for not killing a source dipole, is to create a monopole out of it, so that there's no source dipole to be killed by the demands made upon it by the load. If anything, the load revives it, turns it back into a dipole, and now you've got free energy in any quantity you want, based on the limitations inherent within the entire system, because there's always limits. It's you'd fry the system. The whole thing, would vaporize if the load crossed a certain threshold of maximum safety to operate the system at which point various components, the weak links in the chain, would start to fry and break down. Otherwise, thematically speaking, it could go to infinity if not for the limitations of the materials of construction. The gauge of the wires and whatnot. All those limitations within the various components of the overall system are going to be the only limitation at this point as to how much power that system can create. Because thematically it's already set up to go to infinity. Not bad. So now, in the course of trying to understand the one element of this system I didn't understand, the disruptive discharge of the neon bulb, I figured out how a monopole system of energy, such as Tesla set up at Wardenclyffe, or was in the process of setting up, how it operates. Why is it so enigmatically desirous for an ideal system of powering our loads? I never would have figured it out. And I didn't think I would be able to figure it out in the course of making this video. I just took a chance. Well, I'll turn on the cell phone and maybe it'll come to me. Because it wasn't coming to me just sitting here or laying here. It's just, my mind just wasn't working. But now I think I've figured it out. We create a new dipole involving the load, without which there'd be no dipole in a monopolar system. It's very clever of Tesla. And Barbosa and Leal are taking advantage of it. And I still believe that Nathan Stubblefield managed to do the same thing in his Earth collector, his so-called Earth battery, that he had to call an Earth battery in order to get it past the patent office, who of course would have balked at the thought of an Earth collector. So, Tesla made so many patents because a patent has to be a simple idea. And his systems were far-reaching in their extent, thematically speaking, requiring so many different elements. And there's so many different applications for the same theme, which could justify a whole new patent. So I suspect that what we already know about Wardenclyffe is how to, and what we already know about Barbosa and Leal is how to interpret Tesla's special generator. It's just a different application of the same theme. Instead of remote consumers, you have consumption at the very source of production of energy. And I think that's what Tesla was moving towards, now that I recall the storyline, the byline of Tesla's life story. When he failed at Wardenclyffe, he went to scaling down the system for independent users so that each user had their own little Wardenclyffe in their back pocket, in their backyard. And that might explain the motivation behind Tesla's special generator, was to disengage dependency on a large investment source, such as J.P. Morgan and the like, who could alter Tesla's plans at being magnanimous, something the J.P. Morgans would have nothing to do with. So Tesla realized he had to have each system be independent of a large-scale operation that would require a large investment capital to bring it into being and run it, and instead be more along the scale of each individual user, the home user. Now, the electromechanical watt-hour meter of its day has various elements that could hint to this system, so there's nothing wrong with studying that as a first step, but which I did 2 years ago, but it doesn't have all the answers. As William Line says, it's a watered-down version of Tesla's special generator, and because of that, it's missing a lot of elements, which is why we have to look elsewhere to try to figure this thing out, and that's what I think, hopefully, I've managed to do at this point. But only because of the help of Clarence and Barbosa and Leal. I take it as constructive criticism what Clarence was offering. I don't take it as anything else, because it wouldn't make any sense to take it as anything else. Maybe from his standpoint it was something else, but from my standpoint it was constructive criticism, and it actually helped me. It did not hinder me. It challenged me to review my view of the world, my view of Barbosa and Leal, and reconstruct from scratch the ideology that I was trying to cook up as to analyzing how does it work. But in terms of Tesla's wireless transmission of power, it makes more sense. It makes a lot of sense, actually. And in the course of doing so, I think I understand how a monopolar system works. Why the load becomes the source of energy. Because it creates a dipole, a whole new one, involving the load, intrinsically involving the load as the source of its own power. Amazing. It's truly amazing what Tesla managed to pull off. But he was the, the original thinker, the guy who how do you call it when you plow a field? When you're at the head goose at the front end of the V-shaped formation, like a snowplow does. Trailblazer. So Tesla was the trailblazer, and now he's made it easier for us to reinvent the wheel in this, so to speak, because a lot of his legacy has been lost. But not all of it. Not all of it. Edward Leedskalnin came along and gave us a little hint. Nathan Stubblefield came along and gave us a little hint. I think Nathan Stubblefield, the third coil on top is his load circuit. And the copper wire down below of the bifilar wound primary and secondary, the copper wire is the primary and the iron wire is the secondary, and it's a double use. It's the secondary and oh no, the third coil would be the secondary. That could very well be, that's right. And then the iron wire is the iron core of the toroidal transformers that would otherwise be wound by the primary. So if Nathan Stubblefield did not have access to aluminum wire, he used copper instead, and he insulated it with a cotton sleeve shellacked with a natural sealant of some kind. And that makes more sense. That the third coil, sitting on top of the two larger coils underneath, the third coil is the electric keeper, the wire that loops back upon itself, the secondary of Barbosa and Leal's earth captor circuitry. Of course, as I've stated previously, the reciprocating piston of the Nazi U-boat application of Tesla's special generator, that reciprocating piston substitutes for the primary coil, just the coil, just the primary coil. And the coil wound around the shaft of the reciprocating piston, that is the secondary and would have to loop upon itself. And the shaft could be magnetically coupled to a toroidal iron core that the secondary is wound around. You could have, you cut a donut in half and then you extend it with two straight line pistons, or straight line shafts, I should say, for two pistons that are running in opposite directions, half out of phase of each other, half cycle out of phase with each other. And they stay within the confines of the straight shaft that's stretching this donut out. So it's like a runner's track where you loop around, but there's straight parts too. And then they make the turn at the end of the running track, and they come down the straightaway to the finish line. So we've got two straightaways for two pistons that are running opposed to each other, out of phase by 180 degrees. Actually, we could have four at 90 degrees out of phase. That might be very interesting. In any case, we've got a magnetic keeper in the making here, with no need for a primary winding, because the reciprocating pistons are doing that all for us. Actually, they all have to... Oh, no, if they are 180 degrees out of phase, then that's the equivalence to the two toroids that Clarence made use of to counteract the lens effect within the confines of that secondary endless keeper, the electric keeper, the endless loop. Now that makes perfect sense. So just two pistons operating 180 degrees out of phase. Two aluminum pistons in two iron shafts coupled to a semicircle at each end, coupling the two together to create a magnetic circular keeper, around which is wound a high voltage, very thin gauge wire, similar to the voltage coil in an electromechanical watt-hour meter, but it's connected to itself as an electric keeper. Oh dear. That means it's not wound around the shaft very much. It's only wound a few times. Oh no, wait a minute. It can't be a thin wire. It'd have to be a heavy gauge. Oh my God, that's not at all what William Line was. No, but he was theorizing. He didn't know what kind of... Yeah, he was theorizing a low... Right, ELF. He was theorizing ELF, very low frequency. That's right. We can throw out that speculation in all likelihood. Although 60 cycles is a low frequency of sorts. Why stay at 60? Why not go down to 10? Why not go down to 1? Why not go down to 1 cycle per minute? We don't know what the... Well, but if the reciprocating pistons are reciprocating a 1/16 of an inch, I would imagine it would be a high frequency, not low frequency, because you would have more power gain that way. So, yeah, and that would be perfect for not a long wire, as William Line had imagined, but a short wire. Very heavy gauge, multi-strand, short length of wire that is your secondary of Barbosa and Leal. In other words, an electric keeper. That would make more sense. That's right. Shorter the wire for the higher frequency. That makes sense. Okay. Okie dokie.